Okay, today we have the law of sines, which will help us solve for angles and sides on an oblique triangle. So an oblique triangle is a triangle that contains no right angles. It would either have 3 acute angles or 2 acute angles and 1 obtuse angle. Remember that acute is between 0 and 90, and obtuse is between 90 and 180 degrees. Okay. So here we want to properly label an oblique triangle. So the bottom left corner is always going to be A. So here is going to be A, angle A, and across from angle A is side A. And then next is angle B, which is in the right corner, and across from angle B is side B, and then of course angle C and side C. So this is how you properly label an oblique triangle. Okay. So we have 4 cases of an oblique triangle. Case 1 is when one side and 2 angles are known, angle, side angle, or side angle, angle. Case 2, 2 sides and the angle opposite one of them are known, side, side, angle. And then case 3, 2 sides and an angle are known, side, angle, side. And case 4, all 3 sides are known, side, side, side. So we will just be using the law of sines today, which only holds for case 1 and case 2. Case 3 and case 4 will use the law of cosines, which is what we'll go over on Thursday. Okay. And now here is the theorem for the law of sines. What is that? Who's fire alarm? I hope everything's okay. All right. So the law of sines says for a triangle with sides A, B, and C, and opposite angles A, B, and C, respectively, we get the equation or the formula. Sine of angle A over A is equivalent to sine of angle B over B, which is equivalent to sine of angle C over C. Also, you can reciprocate the formula and get A over sine A equal to B over sine B equal to C over sine C. So this is the formula we will use to solve for the sides and angles of our oblique triangle. And of course, at the end of the class, if you want, I can hopefully prove where these came from. Okay. And then always remember that the 3 angles inside our triangle, no matter what type of triangle, will always equal 180 degrees. Okay. So there's the law of sines. That is what we're using today. So let's try it out. Here we want to solve side angle angle or angle side angle triangles. So it says solve the triangle when A is 40 degrees, B is 60 degrees, and side A is 4. So let me draw a triangle, sure. Into shape on, triangle, oblique, sure. Oh man, already messed that up. Let's try it again. So the tip, start, yeah, there we go. Boom. There we go. Okay. And now label it with the values given. A is 40 degrees. Side A is 4. Side B is 60 degrees. Sorry, angle B is 60 degrees. And we don't know side B or side C, but we can definitely use the law of sines to help us find the remaining pieces. Okay. So we know that we have angle A and side A, which means we can use that to help us find side B since we know angle B. So we're going to call this A. Find side B. And we're going to use actually, if we're doing sides, we're going to use A over sine A equal to B over sine B. Okay, so plug in what we know. Side A is 4, sine of angle A, so you get sine of 40, equal to B over the sine of angle B, which is 60. And yes, that's degrees. Okay, so for this one, we just have to solve for B, which means you can cross multiply. Actually, we don't even have to cross multiply. All we have to do is multiply this sine to the left side. So what that will become is 4 sine of 60 over the sine of 40 equal to B. And make sure that your calculator is now in what?
Degrees.
Degrees. Good. So I'm going to type this in. 4 sine of 60 over the sine of 40. And we get that side B to 2 decimal places is 5.39. All right. Perfect. Okay. Oh, I guess one dead giveaway was that if we know angle A and we know angle B, what is the value of angle C?
80 degrees.
80. There you go. 80. Because they almost add up to 180, right?
Correct.
All right. And now, since we have side B, all we have left to do is find side C. And here we can have use the formula C over the sine of C equal to, and it doesn't matter what you choose now. You can choose A over sine A or B over sine B. I'm going to go with A over sine A only because side A is cleaner. So side A is 4 and side B is 5.39. So I wanted to avoid those decimal numbers. But it doesn't matter. If you choose side B, you'll still get the same answer. But I'm going for cleaner values here. No decimal numbers. Okay, so you get side C over the sine of angle C, which is sine 80, equal to side A over the sine of angle A. Just multiply this sine 80 to the right side. And we get C equals 4 sine 80 over sine of 40. And this will give us side C. So 4 sine 80 over the sine of 40. And we get that side C to 2 decimal places is 6.13. There you go. We have found all the pieces. So I guess we could label that, right? Angle A, angle B, angle C, 40, 60, 80, and then A, B, C for 5.39 and 6.13. Okay. All right. Not bad. We all good with that one?
Yes, sir.
It's all good for now, right? Okay. Let's do it again. Solve the triangle. Angle A is 35, B is 15, and C is 5. So let me draw my triangle. There we go. Label it. A is 35 degrees. B is 15. This means what is angle C?
130.
Good. 130. And all we know is side C, which is 5. Okay. And now we need to solve for A and B. So first step is find side A. Why not? Find side A. And of course, we can use A over the sine of A. And the only complete piece of information we have is side C over sine of angle C. Okay. And of course, you can even make more formulas from these formulas. So if you wanted to make the inputting process faster, you could always have a formula for side A as C times the sine of A over sine C. So just something to have in case you don't like plugging everything in and multiplying to the right, and it'll save you at least one step, right? So here we'll get A equals 5 times the sine of angle A, which is 35 degrees, over the sine of angle C, which we just found out was 130. Type this in, and 5 sine 35 over sine of 130. We get that side A is 3.74. Okay. And then all we have left to do is find side B. And B over sine B equal to C over sine C. Again, I'm just gonna choose the cleaner values just because it's nicer to work with. It won't be like that all the times. Maybe we'll have ugly decimal numbers and just have to deal with them. But if you have clean numbers, just choose those. Manipulate this. C times sine B over sine C. There you go. That's a formula for B, side B. And just plug in what we know. 5 times the sine of 15 over the sine of 130. All right. And type this in. We'll get that side B is 1.69. Okay. So those are the easy cases. Side angle, angle, or angle, side angle. Any questions on this page?
Why can't everything be this easy?
Oh, it's about to get worse. Hmm. 3.74, 1.69, and 5. Cool. All right. Now, on to case 2 for side-side angle triangles. Case 2 has 4 subcases in it. So this applies to triangles for which 2 sides and the angle opposite one of them are known. This is referred to as the ambiguous case because the known information may result in 1 triangle, 2 triangles, or no triangles. The key to determining the possible triangles may be formed from the given information. Depends on the size of side A, the height h, and the fact that height is equal to b times the sine of a. All right. So for the ambiguous cases, here are 4 subcases to determine what type of triangle you have. You'll have no triangle if side A is less than the height. This means that we do not have enough length to form a triangle. You'll have one triangle if side A is equal to the height of the triangle. This means we get a right triangle. We'll have 2 triangles if the height is less than A and side A is less than B. If this is the case, then we have two distinct triangles. And then we'll have one triangle if side A is greater than or equal to B, then only one triangle can be formed. All right. Side note here, if you are not given side A and angle A, then there will be one triangle if the side opposite the given angle is longer than the side adjacent to the given angle, or there will be no triangle if the opposite side is less than or equal to the adjacent side, and you can relate the given information to the above 4 cases. So this is if we're not given angle A, side A and angle A from the problem. Okay. Opposite side is less than or equal to the adjacent side. Gotcha. Okay. All right. So those are the 4 subcases for case 2. So let's try this out. Use the law of sines to solve a side-side angle triangle. So here we're given that side A is 2, side C is 1, and angle C is 50 degrees. All right. So let me draw my triangle. Boom, and then label it from what we know. Here's angle A, and across is side A, which is 2. Here's angle B. We have no idea what B is or side B, but side C, angle C, is 50 degrees, and side C is 1. All right. Okay. So we are given enough information to go ahead and solve for angle A, since we know angle C and side C. So let's go ahead and start with that. Find angle A, which means we're going to use sine of A over A equal to sine of angle C over C. All right. Plug in what we know, and we have sine of angle A over 2 is equal to sine of angle C over C. And then we're going to solve for angle A. So you're going to multiply that 2 to the right side. So you'll get sine of A is equal to 2 times the sine of 50 degrees. It was all over 1. So this means that it's just 2 sine of 50. Okay. Well, next, in order to solve for angle A, you have to get rid of that sine function. So the only way to do that is to apply the what?
Inverse sine?
The inverse sine. And here we get the inverse sine of 2 times the sine of 50 degrees. And somebody punch that in a calculator and tell me what you get.
Domain error.
There you go. We get a domain error, which means how many triangles do we have?
None.
None. Good. So this means that if you get a domain error, this means that there is no triangle. Okay, and this is one of the cases where we weren't given a side A and an angle A. Well, we were given a side A, but we weren't given an angle A. So we could check it. We can check it this way by solving for angle A using the inverse sine, or we can also check it by using that side note that I wrote on the last page. It says there will be no triangle if the opposite side is less than or equal to the adjacent side. So I'm assuming that if this checks out, here this side is 2 and that side is 1. So the opposite side is less than or equal to that adjacent side, if that makes sense. And if it doesn't, then we'll just continue with this method. But following that little side note, if this side is 2 and this side is 1, this adjacent side is less than this side. Therefore, based on the information given, we don't have a triangle.
Less than or equal to, or just less than?
Yeah, less than or equal to. All right. All good with that one?
Yes, sir.
Okay. Next. Solve the triangle. A equals 3, B equals 2, and angle A is 40 degrees. All right. Let's draw my triangle. And here they give us that A is 40 degrees. Side A is 3. And then ugly 3. 3. Side B is 2. And then they give us that we don't know angle B, we don't know angle C, and we don't know side C. Okay, so what we're going to do here is, since we are given a side A and angle A, we can actually now check our ambiguous cases. So what we want to know is do we actually have a triangle? And the first thing we want to find out is the height of this triangle. So remember that height is given by the formula B times the sine of A. So here we have a side B and we have an angle A. So H is going to equal side B, which is 2, times the sine of angle A, which is 40 degrees. And let's see what this gives us. 2 sine of 40 gives me 1.29. So the height of this triangle is 1.29. Okay, so running down the cases, we'll have no triangle. So no triangle if A is less than the height. Is side A less than 1.29?
No.
No. And then we'll have one right triangle if side A is equal to the height. Are those equivalent?
Nope.
Nope. And then we'll have two triangles if height is less than A and A is less than B. Well, we know that the height is definitely less than A, but is A less than B?
No.
Nope. Which brings us to our last case of just one triangle. And we get one triangle if A is greater than or equal to B. And in this case, is A greater than B?
Yes.
There you go. That's how we check our ambiguous cases. All right. So let me just move that up here. We'll just say one triangle because A is greater than or equal to B. Okay, which means that's great news. We have one triangle. So let's go ahead and solve for the rest of it. Okay. So the first thing we can find, I believe, is angle B. Because to find angle B, we know side B. And now we also know angle A and side A. So we're going to find angle B. Okay. And again, if you want more formulas to solve for, well, to solve for angle B at any time, you can use this formula. B is equal to the inverse sine, and I'll put brackets just to be neat, of B sine A over A. And of course, you could replace it if you actually knew angle C instead and side C. So this is just a formula to solve for angle B. Okay, so this means that B is going to equal the inverse sine of side B, which is 2, times the sine of angle A, which is 40 degrees, over side A, which is 3. And we get that angle B, let me type this in, the inverse sine of 2 sine 40 over 3 gives me that angle B to 2 decimal places is 25.37 degrees. Maybe I wrote too big, so let me move that. There we go. Okay. So what this means is that if we have angle B, then we can definitely find angle C. So angle C is going to be 180 minus 40 minus 25.37, which will give me 114.63 degrees. So there you go. We know angle B, we know angle C, and then all we have left to solve for is side C. Which will have C over sine C equal to, who's cleaner? A over sine of angle A. Okay. And of course, your formula here is C equals A sine C over sine A. And we'll get 3 sine of angle C, which is 114.63 degrees, over the sine of angle A, which is 40. Okay. Compute that. I get 3 sine of 114.63 over the sine of 40, and we get side C is 4.24. There we go. All right. Any questions on that process?
So when you're using like sine inverse to find, the angle,
Mhm.
do you still need to remain within like, so for sine negative pi over 2 to pi over 2?
Here, what would it be? I think we're more numerical now. So you have to stay between -1 and 1.
Okay, gotcha.
Yeah. Because now when we're computing these angles, whatever gets plugged into the inverse, that value has to be between -1 and 1. That's
Okay,
why we had that domain error above.
because we were outside of.
Exactly, because 2 sine 50 is what?
I couldn't tell you.
2 sine 50 is 1.53, which is definitely above.
Yeah.
One.
Okay. So because it was what 2 sine 50.
Yeah.
Yeah. Sine. Yeah. Okay. Gotcha.
Got it?
Okay. Well, so you do sine inverse 2 sine of 40 over 3,
Yes.
and that
You
gives
mean
you
to,
25.37 though.
what's that?
And that gives you 25.37 though. So it's just
Yes.
like what you plug in.
That's
that you
it.
Watch out for. So like say 2 sine 40 divided.
So 2 sine 40 divided by 3 is 0.428.
Okay, and then you're using the sine inverse to get.
And then you apply the inverse. And since that number is between -1 and 1, remember when you apply the inverse, it's now you're plugging in a numerical value in order to get an angular output.
Okay, I got you.
Got it?
Yeah.
All right. Does anybody need to see these put on a calculator?
Why not?
Not that, but I was gonna ask. So when you're running through your checklist for them to roll your ambiguous triangles or whatever cases, is there a certain order you can go by, or is there a certain like if you do the third case first, that would rule out 1 and 2 or something of that nature, or is it just you have to go through all of them?
You can go in any order. I was just going through all 4 to show you how to check them off. I mean, you can. I would recommend checking all 4 just to do it. But I mean, you could probably get away by just checking 1 because you're like, okay, it's definitely not equal to, it's not less than, but I mean, one triangle is the easiest. We could have checked that off our list a while ago. A is definitely greater than B. But again, the more times I show you how to do it, the faster you'll be at it because you'll be like, okay, that's greater than, so that's definitely 1. But if you run down that checklist, it just gets you more familiar with what type of triangles you have. Okay. All right. Cool. All right. Next one. Given A equals 6 and B equals 8, and angle A is 35. All right. There we go. Label. Stop it. Oh, just change the color there. Bam, bam, bam. Angle A is 35 degrees. We don't know angle B or angle C, but we know side A is 6 And side B is 8. We don't know side C. Okay, what's up?
Let's check them because
Let's check them. So the first thing we want to find is height, right?
sure.
B sine A.
B sine A. So height is going to be 8 times the sine of 35 degrees. And height, so 8 sine 35. We get 4.59. Okay, and again, if you checked your cases, is A less than, so this would be for no triangle, right? For no triangle. Is A less than the height?
No.
No. And for a right triangle, is A equal to the height?
No.
No. And for two triangles, is A, actually here, I'll write the other way, is the height less than A, and is A greater than B?
Less than B.
Sorry, did I say the opposite? So if height less than A, and is A greater than B?
Less than B.
Yes, less than B. Height less than A less than B.
That looks like our guy right there.
There we go. Once I say it correctly, right?
Yes, sir.
There we go. So we have two triangles. All right, so that's where we stop. We have two triangles. All right, two triangles. Height is less than A, and I got this, A is less than B.
I believe in you, sir.
There we go. I got it. A is less than B.
It's okay.
Good.
Words are hard.
Yes. Okay, so we have two triangles. So we're going to have to figure this out. Okay, so based on the diagram from our ambiguous cases, this is the way we're going to have to draw it. So I'm going to put from the top. Actually, I shouldn't have dashed it. Oh, well. This is how we're going to have to draw our two triangles inside this one triangle. Okay, so what this means is that since that's angle A, this means that side A is not only here, but side A is also going to be here. All right. And again, the way I'm drawing that is just based off the ambiguous case. Okay. So now let's go ahead and just find information for our first triangle, which means when I label the rest of this, this is now, we're going to call this angle B2. And then up here, this is now going to be angle C2. Okay. So let's go ahead and find the angles and information for the big triangle. All right. So with that being said.
Wait, real fast. So like when it says two triangles, does it really mean three triangles?
No, well, it looks like three triangles, but just keep it as two.
so like the big one and then a small one inside.
Exactly. So it's the big one and it's this one.
Okay, I was gonna say there isn't like a side C3. I mean angle C3.
No. Just two
Well,
triangles.
okay. Well, why not? Why would we not have to find that third one?
Just cause, okay?
You know what? That's enough for me.
Just cause. All right. Where would the third one be? Oh, right there. Oh, I think you can't consider that, because if you're saying you have 3 triangles, then you would be saying that this side is also 8, when it's actually how long?
4.59.
It's 6.
Oh, yeah.
It's not the height. Height would be straight down. That would be the 4.59.
Okay,
Yeah.
so when it's 6, you'd also be saying it's 8. So it's just not possible. To,
Exactly.
I
Not
mean,
possible.
Couldn't you still find like the values for it though? Or
No.
you couldn't?
No.
All right.
It's 6. Can't change, right? That means, yeah, you definitely have another angle B, but you couldn't have a B3 because it would still be the angle as B.
Okay. So
Yeah.
what if they're equal? Doesn't that give us? Isn't that another? Isn't that like a whole other like triangle thing?
If the height was equal to A, then it's just the right triangle.
Oh, but equal.
And if A was equal to B, it would just be one triangle, one oblique triangle.
So what is that like empty space? I mean, I get that it's like part of the first triangle, but like why? You just can't.
So you just have to use your imagination and just ignore this part.
Okay.
It's dark matter, it doesn't exist.
Because I mean, if it makes it better, we could split it.
Yeah.
And have that there. And then this whole triangle you would have there. So that makes it better for you to visualize it. Just split it
Doesn't
into
it
2.
kind of look like a right triangle though?
No, it can't be.
No.
Sorry, that should be more slanted. That's what I do when I freehand, okay?
True.
So just imagine they're split into 2. That's just the best way to look at it. I normally don't draw the double triangle at the beginning. I do it at the end to avoid confusion and questions like that.
What just happened here?
Exactly. Okay, so we're going to look at the big triangle and we're going to solve for angle B because we know angle A, and side B. So that's what we're going to do first. So find angle B. Okay. And we're going to do sine B over B equal to sine A over A. And of course, you could rearrange the whole thing and you'll get B equals the inverse sine of B sine A over A. And B would be the inverse sine of 8 times the sine of angle A, which is 35, over side A, which is 6. Okay, and then B, angle B is going to be 49.89 degrees. Which means that if we know angle A and if we know angle B, this means we can solve for angle C. And that's going to be 180 minus 35 minus 49.89. And we should get, for angle C, what is that?
95.11.
95.11.
Let me do the calculator to make sure. Yeah, that's good.
Good. All right. Good. So now we have angle B, angle C, and all we need to do is solve for side C now. Which is going to be C over sine of C equal to A's cleaner, right? Yeah. A over the sine of A. And C is A sine C over the sine of A. Okay. So this means that C is going to be, what is that? 6 times the sine of 95.11 over the sine of 35. Okay. And then calculate 6 sine 95.11 over the sine of 35. And we get that, we get 10.42. All right. And that is for the big triangle. All right. And sure, maybe we could draw that big triangle down below by itself. No. Actually, watch this. Ooh, 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 bam.
Beautiful.
And you'd have 35, 6, and then B is 49.89. And there is 8. And then you have 95.11 and 10.42. There you go. That's for the big triangle. And now let's solve for the inner triangle or the second triangle. Okay, so looking at our diagram again, one thing's for sure is that angle A is 35 degrees. And then side A is still 6. And then one thing we don't know is that we need side B2. Or not side B2, angle B2. Okay. And we can get that. Let me check something. Let's see if
that
this
angle
works.
would be obtuse, right?
What's that?
That angle would be obtuse.
Yeah, that one's going to be obtuse.
Okay, so the regular way does not work with it then.
Because what did you get?
I got the exact same thing as the angle for the first triangle for B.
Oh, okay, yeah, because if you did B2, right? If you did B2, you'd get the inverse sine of 8 sine 35, right?
No, 6 sine. Oh wait, no. Yeah, 8 sine 35 over 6. Oh,
Over 6, which
yeah.
is the same thing we did there, right?
Well, hold on.
Yeah,
I
that's
mean,
that's the same thing we did there. So in order to find B2, we're actually,
oh yeah, it is.
since we know we have two triangles, what we have to do here to find angle B2 is take 180 degrees and subtract angle B.
And why do we do, okay, like how exactly does that work?
What is it called? Is it supplementary?
Complementary?
It's either supplementary or complementary while we subtract 180 to get that value.
Oh, so it gives us like the opposite of its obtuse to 180. Wouldn't
Yeah.
it be 90 degrees then?
No, not 90.
Okay. Okay, 180, because
What?
think of it as like a straight line, right?
So you
How
do
does-
180. What's that?
How does that work? Because I thought that only worked for, that little not real angle on
Like
the other side
if
of
you
it. Yeah,
did
I
this,
thought that
right?
works for that. Yeah.
If you did that. Because
Yeah.
that is, I might have the wrong wording. Supplementary, complementary. It can also, what is it? It also
I
deals with
think I understand.
inverses, but yeah. Let me find the right wording. We'll get back to that. But to find that other angle is we will subtract it from 180. Hang on. Give me a moment. Yeah. So to find that, I guess it would make sense. Let me see. Because if we're looking at just this triangle, we know one angle is 35 degrees, right?
Yes, sir.
So to find, we know the total is going to be 180. So in order to find angle B, you would just take that 180 and you would subtract. So you would take that 180 and subtract the original angle of B to find B2.
And that's just how it works.
That's just how it works.
Okay, that's yeah.
Yeah, I'll just go with that.
Yeah.
Yeah.
See that.
I mean, the reasonings is definitely a little complicated because you can say that angle A plus that angle B have to be less than 180. So whatever's inside there has to be less than 180. So in order to get angle B, you just subtract it from 180. But let's just go on that good word, right?
If you're
Sounds
saying
good.
it, I'll trust this one.
All right. Oh, trying to find the better explanation, but we'll look at it after. We'll come back to that. Okay. All right, so we have B2, which means we can now find angle C2 by taking 180 and subtracting angle A, 35 degrees, and subtracting angle B, 49.89 degrees. And this will give us what?
So first, wait, okay, so for C2, well, you put 49.89 as the,
Oh, sorry.
There you
Yeah.
put the wrong one in there.
Yeah, whoops, put it the wrong way. So this should be 49.89, right?
yeah,
Okay, so what does that give me?
130.11.
130.11 degrees. Good. And then now we do 180 minus 35 minus 130.11, and we'll get what?
$19.89. Nope.
14. There you go.
14.89.
14.89. We guess we should label this, right? Small triangle. And then big triangle. Okay. Cool. Okay, so we have angle B2, C2, and angle A stays the same at 35 degrees. And then all we need left is, what is it? We need side C2. Because everything else stays the same. So this is side C2. Okay. So you'll get side C2 under the sine of angle C2 equal to, well, what we know already, side A over the sine of 30, over the sine of angle A. Now just solve for C2 and you'll get A sine C2 over the sine of angle A. And C2 is going to be 6 times the sine of 14.89 degrees over the sine of angle A, which is 35. And side C2 is going to be
2.69.
2.69. Good. There you go. And now we have all the pieces for that triangle. So let me see. That one looked like that. Good enough. And this was 35. This was still 6. This was 130.11. And then the top was 14.89. And here's 8, and here's 2.69. And there we go. That's what we do for our two triangles. Ooh, boy.
That legit was like 30 minutes.
Wasn't that long, maybe 15. What was it? Okay, everybody go with that one?
Yeah, that was fun. Talk about good times, man.
Mm-hmm. Is it because swinging it is 180? Ugh, I hate it. All right, we'll get back to that later. Now it's going to bother me. All right. Okay, now on to word problems. All right. To measure the height of a mountain, a surveyor takes 2 sightings of the peak at a distance 900 meters apart on a direct line to the mountain. The first observation results in an angle of elevation of 47 degrees, and the second results in an angle of elevation of 35 degrees. If the transit is 2 meters high, what is the height h of the mountain?
What's a transit?
The transit, you know, when you see those people on the side of the highway with those tripod big yellow things?
Yeah.
Yeah, that's a transit. It's like they're taking pictures of the road and everything. So that's what a transit is. All right. Let me see something. I'm going to, let me see, hide this. Insert picture from online. And I want the picture of a mountain instead of drawing one.
Guy taking a picture.
But you're such a great artist.
I know. Yeah, look at those are too complicated, right? My mountain's cooler. It's like the one from Adventure Time. Watch this.
It's a great show. All right, it's just a great show.
There's my mountain. All right. So what we say is that the surveyor takes 2 sightings of the peak at a distance 900 meters apart on a direct line. So this means that here's going to be our first sighting. Oh, I want straight lines. Give me straight lines. Let's see. Nope, it's like you have a terrible line. How about that? Bam. There's our first sighting. And then he takes another sighting 900 meters apart. Okay, so then here we go. Boom, 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 boom. Right there, why not? Okay.
Well, couldn't you just go to like the other side of the mountain?
No, because it's 900 meters apart on a direct line.
Man, these word problems.
Yep. So it's all about the diagram setup. So this is going to be the 900 meters apart. And then we want to know the height of the mountain. So that means that we're coming down here. And then one more. There we go. Okay. So labeling everything else, it says that the first observation results in an angle of elevation of 47 degrees. So remember, angle of elevation means we're looking up. So this is the first sighting at 47 degrees. And then the surveyor walks 900 meters apart to get the second sighting, which is at 35 degrees. And then we have a transit that is 2 meters high. So actually I could have drawn my mountain a little better. Let me see. All good. It's still not hurting. Here's our transit that's 2 meters high. Okay, so this means my actual mountain base is down there. Okay.
But 2 meters by 2 meters?
Yeah, because he set up the transit, which accounts for 2 meters, which accounts for also the height of the mountain.
Okay.
So let me draw that down there. Here. There
So
we go.
it took the angle of elevation off of the very top of that transit when the actual ground is 2 meters below it.
Okay, so we're starting at the base of the mountain to the transit, which is 2 meters. And at that first sighting was at 47 and that second was at 35. Okay, and all we want to do now is find the height of the mountain. So we're gonna look for this, H. Okay, so the way to do that is we can see that we clearly have 2 triangles, but we can use the sine function to help us with this. but we'll have to get there because we could say, if you look at the bigger triangle, we could say the sine of 35 degrees will be equal to opposite over the hypotenuse. So the sine of 35 is going to equal h over the hypotenuse, which we'll label x over x. And if we can find the value of x, this means we can find the height of the mountain.
Plus 2 meters.
Plus 2 meters. Good. So let's go ahead and get that set up. And one thing that we can clearly see is this angle here. If that's 47 degrees, what is this angle?
$133.
133.
Good. 133, which means what would make this angle?
$12.
I got -12, but I think I
There you go, 12. So now we actually have enough information to solve for x, which means now we are focusing on the inner triangle, which means we can use law of sines to solve for x. So that's where we're going to start first. Let me erase this. We'll come back to that in a second. And we're going to say find x. And to do that, we can use the law of sines. So we're going to have x. What side is, what angle is opposite x? Is that 133?
Yes.
Yeah, so you're going to have x over the sine of 133 degrees equal to what we know already, 12 degrees and 900 match up. So we're going to get 900 meters over the sine of 12 degrees. Okay, this means that x is going to equal 900 times the sine of 133 degrees over the sine of 12 degrees. And we get that the hypotenuse, or the value of x, is what?
3,165.86
meters. Good. Okay, but we're not done because that is just the hypotenuse that leads us to the tip of the mountain, right? Which means we can now come back to that sine function. And we're going to say find h. And we're going to get the sine of 35 degrees is now equal to opposite. So the sine of this 35 is going to be equal to h over the hypotenuse of 3,165.86.
And they're just going to multiply it, right?
Meters. And that's it. So you're going to have 3,165.86 times the sine of 35 degrees equal to h. And what do we get?
1,815.86.
1,815.86 meters is equal to the height, but we
You
have to add the what?
2 meters.
2. Good. So it's going to be 1815.86 meters plus the 2 meters. So our height is 1817.86 meters. There you go.
That was better than the double triangle from the previous one.
Yeah.
This was kind of fun.
That was a lot better. Well, we didn't have to find the value of the, well, I guess we wouldn't even consider that an inner triangle. I don't even want to think about it. Let's move on.
Yeah, you can't consider it because then
Exactly. Then the world will explode. Let's keep moving. All right. All right. Coast Guard Station Zulu is located 120 miles due west of Station X-ray. A ship at sea sends an SOS call that is received by each station. The call to Station Zulu indicates that the bearing of the ship from Zulu is 40 degrees east of north, and the call to Station X-ray indicates that the bearing of the ship from X-ray is 30 degrees west of north. How far is each station from the ship? All right. So all about the diagram here, right?
I'm just gonna have such a bad time with these word problems.
So first off, we know we're going to have a triangle. Okay. And now what we know is that, let's see, Zulu is located 120 miles due west of X-ray. So
Would
here
that be
is,
side C?
well, yeah, that's going to be side C. Good. So there's Zulu, here's X-ray, and they are 120 miles apart, right? Okay. And then we see that a ship at sea, here's my ship. There's our ship. Sends out an SOS, and the call to Station Zulu indicates that the bearing of the ship is 40 degrees east of north. So if we're going east of north or northeast, this means that this angle here is 40 degrees. That makes sense?
Yeah.
So then the other one had to be 50.
Exactly. So down here would be 50. And then for Station X-ray, they got the call that it was 30 degrees west of north, which would then make this angle
60.
60, which means angle C is what?
110.
110. Okay. Well, now we want to know how far is each station
No,
from.
wait, no, sorry, it's not 110. It's 70.
Oh my goodness. 70.
Making me
So here is the length for Zulu, and here is the length for X-ray. And we want to know how far is each of them from the boat. So we're going to say find side Z. And using our law of sines, we know that to find Z, you'll get Z over the sine of 60 degrees equal to 120 over the sine of 70. And then to find Z, you'll have 120 times the sine of 60 over the sine of 70. And what does that give us? You should get 110.59 miles. And then for side X, you get X over the sine of 50 equal to the same thing, 120 over the sine of 70. And X equals 120 sine of 50 over sine 70. And we'll get that X is equal to
97.82.
Yeah, I got 97.82.
82.
Yeah.
Okay. We'll have 82.
Well, so. Oh, okay, okay. Well, okay. So side, wouldn't they just be like the other way around? Okay, okay. No, no. You know what? No, I get why you did it the way you did, but the
Oh,
labeling just like totally effed me up.
yeah. I hear you. Okay, so we have how far each station is, and now we want to know if a helicopter capable of flying 200 miles per hour is dispatched from the nearest station to the ship, how long will it take to reach the ship? All right, who's the nearest station?
X.
Yeah,
Good, so X-ray, right? So here we're going to use that simple distance formula. Distance equals rate times time. So we have to travel 97.83 miles.
It's 82.
And how fast is this helicopter going?
200 miles per hour.
200 miles per hour times time. So then we're going to divide by
200 miles per hour.
200 miles per hour. Where your units of miles will
Cancel.
And what is 97.82 over 200?
0.49
So
of
we
an
can,
hour. I mean, you could probably just convert it to minutes, right?
yeah, because this says 0.49 hours.
Yeah.
So we could say half an hour, but if you want to convert it to minutes, you know that there are 60 minutes in 1 hour, right? I mean, we didn't have to do that. You can just take 0.49 and multiply it by 60. And how many minutes will our helicopter be there?
29.35.
29.35 or 29.4 minutes. There you go. Yeah, these problems are definitely way better than just working the triangles above.
I don't know. That like
0.49.
conceptual stuff is pretty good.
All right.
Eh.
You all good on? All good on this one?
Yes.
Man, we lost a lot of people.
I don't think there's many here to begin with.
Nah.
Oh no. Of course.
All right. Cool.
Uh,
Just a few. Okay. Let's keep going. We have 20 minutes left. We got this. All right. A triangular plot of land has one side along a straight road measuring 200 feet. A second side makes a 50-degree angle with the road, and the third side makes a 43-degree angle with the road. How long are the other two sides of this triangle? All right. So here's our triangle. Bam. And then let me draw my road. Look at this. So it's one side along a straight road. Okay, so I have all my shapes. Yeah, look at that. Here's my road. Probably don't need my road, but I'm putting it there anyways. Boom, 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 boom. All right. And now we say that another side of this triangle makes a 50-degree angle with the road. So we'll just say that this part's 50 degrees. And then the third side makes a 43-degree angle with the road. And this road is how long? or not the road, but the triangle,
200 feet.
200 feet. Okay, and now we know that if we have 50 and 43, what is angle C?
87.
Sure about that?
77.
All right. So here's side A, side B, and we just have to use the law of sines to find them. This problem is not bad. Side A over sine A equal to, we know C over, actually, let's just plug in what we know. A over the sine of 50 equal to 200 over the sine of 87, and A equals 200 sine 50 over the sine of 87. And side A is going to give me 153.42 feet. Move that over. Bam. And then side B is B over the sine of 43 degrees equal to the same exact thing. B is 200 sine of 43 over sine of 87. And side B is 136.59 feet. There we go. Easy peasy.
Lemon squeezy.
All right, all good on that one?
Yep.
All right.
Mhm.
Last one. Pat needs to determine the height of a tree before cutting it down to be sure that it will not fall on a nearby fence. The angle of elevation of the tree from one position on a flat path from the tree is 30 degrees, and a second position 40 feet farther along this path is 20 degrees. What is the height of the tree? So this will be just like that mountain one, right? There's my tree. Oh, it'll be orange, sure. And tree branches. Creepy tree. Okay, so at our first look to the top of the tree, there's the first one. And then we'll have a second observation. Oop. Good enough. Okay. So the first angle of elevation of the tree from one position on a flat path is 30 degrees. And then the second position, which is 40 feet further along the path, so here's 40 feet, will be 20 degrees. Okay. What is the height of the tree? So we're looking for the height of the tree. Okay. So this is just like the mountain one. We can find this angle. If that's 30, what is this angle?
150.
150. And what's the remaining angle?
10.
10. And here we want to know what x is. So let's do it. You'll get x over the sine of 150 equal to 40 over the sine of 10. X equals 40 sine of 150 over the sine of 10. And the hypotenuse is going to be 115.18 feet. Okay. So now we know the hypotenuse is 115.18. And now you look at the bigger triangle and we apply the sine function. So find height. Sine of 20 degrees is going to be h over 115.18 feet. Multiply that to the left side. And the height of this tree is 39.39 feet. Boom, boom, boom. Any questions on that one?
No, sir.
Can I have the hour and a half of my life back?
Never. All right.
Was that the last one?
That was the last one.
Oh, cool, cool. Now all of this was cool and all, but I think you know what we want next.
What?
Oh,
the
The proof?
proof, yes, sir. Hey, you asked. You were like, if y'all want, and I was
That's
like,
true.
he shouldn't have said it. He should not have said it.
Hey, let's see. So for two triangles, yeah, that's it. There's no other explanation other than just to subtract it from 180 to find the second angle.
by the way, you're still recording.
I know. I know.
No, it's the proof from
Yeah,
the trivia.
we'll do the proof. But I'm just talking about for the two triangles,
Yeah.
it's just everywhere you look up, it's just like the second angle is found from subtracting it from 180.
Like, okay.
Yeah, I'll just go with it. I'm
Yeah.
pretty sure you said
So,
that in
like,
some
okay, so-
super high up math class, there's a reasoning for it, but I'm never
No,
going to take that.
I'm
So
pretty
I'll
sure-
take the
I mean-
180.
Okay,
could
I kind
be-
of understand though.
And it could be dealing with inverses too. But-
Okay, but, well, let me. Okay, so I kind of understand because it says that the inside triangle, that's not the small one, is not a real triangle, right? Or like what we're supposed to not consider.
Yeah.
So okay, yeah, going back to it then. Okay, so you said it's b minus 180, right? And that would give you the obtuse of the other side, but it's like you see that this side in here is what I would assume acute, and it's like we're not supposed to consider this, so you can't consider that side to be acute, you know, the side behind b2.
Mm-hmm.
Yeah, so it's like, to me, I guess it kind of makes sense
Yeah.
in a weird
If
way.
it works out that way, like, because yeah, this would be like that, right?
Yeah.
So that would be considered 180 minus B,
Hmm.
but could be a thing.
But it's
All right.
like it's acute, so it's like, we can't consider it, so it shouldn't be acute anyway, because the other side is acute, and then 180 minus b is acute. Oh wait, no, I just thought
All right.
I'm
Let me
confused,
stop recording on this before we confuse anybody else.
bro.